Tech Nuggets, Nmap. Today we're going to talk a little about Nmap, which is a really great tool. It's been around a long time. It's an open source tool, and it stands for Network Mapper. It's a network discovery tool. Comes in Linux, comes in Windows. In Windows, it's called Nmap, has a little GUI that goes with it that makes it a little easier to play with and look at. It can show you a graphic representation of what you're seeing. But the basic deal is it's going to go and scan at least one IP address, either v4 or v6, or an entire network. It sort of just depends on the command line options. Oftentimes, this tool has been considered sort of a Swiss Army knife, as it is quite old. Lots of stuff's been added to it. It can do a number of different kinds of scans of a particular machine or of all machines on a network that it finds. So it can be, we're going to break it down into a couple different parts so that we can understand how it works, because it does do a bunch of different things. And I'm only going to cover kind of the basics of what this tool can do. Documentation will cover very specific corner cases. If you're looking for a specific thing, you may need to go dig through the manual to do that. So Network Mapper can do network discovery. So it'll scan an entire subnet looking for hosts, IP addresses that respond to ping or respond to some other test that you give it. The standard one is ping. If it responds to ping, it'll go back to those that it sees have responded to its discovery and then do some level of basic fingerprinting. So it'll start poking all the different ports. So maybe all the known ports from, 1 to 1024, or if you give it additional ports that you want it to go look for. So I want it to look for all services on port 27.0. It'll go look for that, either TCP or UDP or both. So it can do those kinds of things. That's the basic gist of what Network Mapper does. It was originally built by the author to scan a network and find services. So web servers, SSH servers, telnet servers, FTP servers, mail servers, SNMP servers, all those kind of things exist on ports, on a host. So it's designed to sort of give a broad understanding of what can be seen on a network. Now remember, that will be from the positionality of whatever machine is running Nmap. So if Nmap is, blocked by a firewall, not going to see it. Blocked by a NAT, not going to see it. It's not going to be able to scan those kinds of things unless the machine running Nmap is in a position to actually see those services. So you sort of have to keep that in mind when you run it. That Nmap can't see everything. It's not omniscient in some weird way. It can only see what can be seen from that machine. So you may need to run those tests from a variety of hosts to be able to get different angles on a particular device if it has multiple Ethernet ports or things like that. All right. So some of the basic features here of Nmap are scanning a network or a defined range of IPs. If you only need 10, you don't have to use networks. You can say, I want to go from, this IP address to that IP address. It'll scan for open ports. And when we say that, we mean ports that have a service sitting on them waiting. A web server is a great example. It can sit on port 80. If it's doing secure web, it'll be sitting on maybe 443. And those ports will be considered, quote, open. And that's kind of what that means when we talk about open ports. It means there's something sitting on it waiting for packets to show up. It's a service that is opened that port, and opening a socket would be the programmery way to kind of say that. We've opened a socket, so we've opened a port to do that kind of stuff. Once it's done its network scan, it will go back and scan for open ports on those hosts. So it'll say, oh, well, can I poke? And it'll just start at 1 and work its way down. Now you can define in the command line what the range of ports that it's going to poke is. So if you just want to poke, I want to look and see if it only has SSH. Great, just go poke port 22. That doesn't mean that every machine that has a reactive port 22 is an SSH server, but it's a good indicator. And it doesn't mean you couldn't move your SSH server if you were running those hosts to a different port and Nmap wouldn't find it. You can do those things. Typically, 22 is where we would put our SSH server. So if we went and did a scan for that, just looking for port 22, we're likely to find that. The last thing it does is basic fingerprinting of services, if possible. So we know it's port 22. We can poke it and it'll respond with an open packet and say, yep, I can respond to packets here. And we might be able to do some basic fingerprinting of what's going on. Now, SSH is kind of a bad example of this, but if we were to do some DNS poking and you're a DNS server, we can run several queries, and the way it responds might tell us what version of the DNS server. Using bind 8, using bind 9, I can tell basic versioning of what's going on with some of that. And the same is true with web servers. We can fingerprint. You use an Apache, you use an Nginx, you use an IIS. What are you using? And so it'll do a little basic fingerprinting of what version of the service are you doing. And in fact, you can do some more detailed versions of that. With Nmap, it's been used for penetration testing to do some of that. Are you the up-to-date version of bind? Are you the most up-to-date version of IIS? Have patches been run? So you can begin to get into some dark territory with this as a pen testing tool, penetration testing tool. That all being said, I have an entire slide with the word danger on it here because this is a tool that can be used for evil. Straight up. You can use it and get in a lot of trouble. You can have it turn it loose on, entire networks that are not yours, that you are not legally allowed to run this tool on, and it will get you in trouble. Both legal trouble, if you're at work and you start doing this, it can get you fired. You want to be careful with it. This is the kind of loaded gun tool that the bad guys use to poke around on people's networks. And if you start poking 5, 15, 20 machines all at once, and their intrusion detection software notices it and says, look, that IP address is doing that with Nmap, they'll track it right back to you. So you be real careful with these tools. It's no joke. You get a lot of trouble. All right, so danger over. Dun, dun, dun. Nmap. Nmap advanced use kind of breaks down into these categories I've shown here. There's target specification and host discovery, and we kind of talked about that. But we can also go in and do some real basic scan techniques. So if I want to do more specific kind of things, I know I'm kind of looking for one thing. And that means that I'm looking maybe for a TCP scan. HTTP servers don't usually respond on UDP scans. They don't do a lot of UDP. They could, and maybe I need to do that. So we can look for UDP or TCP, and there's command line options that we can use in Nmap to do very specific things. And some of this is very corner case. No arguments there. If you're looking for specific information, a lot of times Nmap's got an option for it, so that can be very useful. Again, with port specifications, we can be doing that kind of stuff where we're looking for SSH or we're looking for a specific service, and it's often on a specific port. We can specify those ports as we go along, and there's specific options that'll go with that. OS detection is quite nice. There's some options where it will go and poke the remote box and can begin to get some basic understandings of, hey, this is running this version of Linux or that version of Windows or this version of Mac OS. It can do some fingerprinting and understanding of what's out there. So if you know what should be out there and you begin to go look for, specific OSs and you're seeing some unusual things, can lead you down the path of, hey, what's going on? Let's go look. Miscellaneous options are kind of nice because occasionally you need to do, again, a specific kind of test. And in this case, we're talking about, hey, I want to force an IPv6 test or an IPv4 test, or I'd like a specific formatting output for my data. I don't want it to come out in the standard output format. I want it to come out in this output. I want to see these things to be highlighted. To make it a little easier, if you write it in a script and you're poking 1,000 machines, sometimes this matters. If you're only poking one machine, it probably doesn't matter as much. But sometimes the outputting options can be quite useful. All right, so we'll go on to the practical demonstration where I'll run Nmap in a couple different situations. I'll run ZenMap, and we can see the cool graphic map that it makes, and we'll be able to talk a little about that. All right, so I've got GNS3 set up here, and I've got some, targets set up that we can scan. So let's go over our network a little bit, and that way we'll have a basic understanding of what's going on. So I've got the 172.21.0.0/24 network set up here, and I've kind of laid out the IP addresses on one side so you can see them a little easier. But down the side, we've got a 2019 target, Windows 2019. We've got an Ubuntu GUI, which is target 2, and we've got an Ubuntu CLI, or server, which is target 3. And across the bottom, we've got a 2019 PRTG server, which we're going to use for ZenMap. And then there's an Ubuntu GUI, which we're going to use for the Nmap CLI, so we can sort of see different ways output is. The left side here is for a different lab. You can see there's another Voyos and kind of things like that. We're not going to worry too much about that at this point. But laid out the IP addresses here so you can see them, and that way when I'm talking about different, I'll be typing in IP addresses, and you'll be able to tell what's going on and which one I'm scanning and that kind of thing. One of the things I learned while I was doing this, it gets a little odd when you Nmap yourself. So it's generally, depending on how the software decides to hook into the networking stack, you can get some very odd results if you try to Nmap or ZenMap yourself. So if I run Nmap and then put my own IP address in, might get some very weird results. And it really will just depend on the operating system and the hooks that it has in the kernel for Nmap and these kind of things. It's not recommended. So that's why I set up these 3 targets so that we would have some things that we could scan and look at and work with, and we wouldn't necessarily be, messing ourselves up doing it. We can put in a range, right? We'll be able to put in 52 through 54, get our 3 targets, and that'll give us a nice range. We can play with it. All right, on to the tests. All right, so what I have here, I've opened up Ubuntu GUI, which was at the bottom, right? Not one of our target machines, and the Windows 2019 PRTG server, which we'll run Nmap on, and that way we can kind of see both of them. I'm going to run 3 different kind of scans, and we're going to talk a little about them. They're the kind of basic thing you would do with Nmap, and the difference between Nmap and Nmap are not so much in the tests that are done, but in the way the output is collated and held onto and that kind of thing. So first thing we're going to do is this -SN is just going to do a ping scan of the whole network. So I'm going to talk a little bit while it does that, but basically it's going to go out and just poke everything it can find. And if it finds an IP address, it will use its local DNS server to try to resolve to it. So you can see it got reports back. These are all the things that it got reports back. It poked 256 addresses. It finds 6 of them up. Doesn't take very long. 1 ping packet apiece. It's a pretty straightforward thing. We can come over here to Nmap, do the same kind of thing. You'll notice it builds the command line here, but we can put it in a target. We can pull down ping scan and it'll pick the same thing and we can hit scan. Again, shouldn't take very long. Should go through and build a basic ping scan map of what we want. Now, we can track this kind of stuff using the command line over here in Ubuntu, in an Excel spreadsheet or in something like that if we wanted to know a little more about the data. Nmap will track all the different hosts down the side. One of the joys of Nmap is that as you run successive scans, so you run this scan and then that scan and then this scan, it will collate all the data for all those scans together. So you can look at different things like, what do I see for topology, right? Here we go. We can see all of our hosts. They're very, very small, unfortunately. And no matter what happens, you can make them bigger and they never seem to get as big as you'd like. Whoops, I hit save graphic. There we go. Controls. And we can make it big. There you go. That was big. Hope you wanted it big because it doesn't get very big. But we can look at legend and it'll tell us things like posts with fewer than 3 open ports. Well, we only pinged it, so it only knows about that. So we can learn a little about it as we look at the graphic. We can click on the graphic and it'll sort of reorient the graphic with that object as the center. What do I have to go through, or what did I have to go through to do that? Most of the time in Nmap, you want to know, if it knows it's a router and it has to bounce through a router to get out, it'll show you that kind of stuff. Since it doesn't know down the side what they are, those are little monitors with question marks on them. But as we go along, it may be able to figure out what it's doing and what the OS is. And those are some of the other kind of scans that we're going to talk about here in just a second. The other thing you can see is some host details, right? As we click along on different hosts, it may be able to pick up MAC addresses. Again, as we do more scans, it will be able to pick up more and more information. And you can see the history of commands that you ran that generated this amalgamation of data. So you can see the different things that you ran when you did it. All right, so a few of these tests take quite a while to run, actually. So I ran them, and we're going to talk about the output here because they took about 3 minutes to run in each case. So what I ran here is an OS scan. So you'll see at the top I've run nmap dash lowercase s uppercase v against the IP address for the Windows 2019 target, which is going to go and do basically a TCP ping scan. It's going to try to fingerprint and thumbprint what's going on for the OS. Now, we know that it's a 2019 box because I told you it is, and I know when it's installed, and I've seen it. So you'll just have to take my word for it, I guess. It's guessing, based on what it's seeing coming back, that it's a Windows 2008 R2, maybe 2012 box. So it's not too far off in that respect. And the same thing is true over here when we scan it from the other side. You'll see very similar results come back. We'll go over here and click on it. And now all of a sudden we get some ports and hosts. As we look at different things, it's decided, yeah, these are actually open. And when the ports disappear, when the next time we run a scan and it's not there anymore, it'll list the port, but it'll turn the color red. So we know that at one point there was something there and now there's not. So our topology should change, right? Now all of a sudden our legend said that, a router has more than 6 open ports. So that's what the colors mean, is that we're going to get more and more, and they're going to get larger as we go along. So we'll be able to see a little more about the host details, anything that goes on that it happens to know. We scanned 1,000 ports on it, probably the lower 1024 ports. Most ports were closed, that kind of thing. All right, so this is the last scan that I wanted to do. It's considered an aggressive scan. At least that's an Nmap term for it. I would have said it was probably just more verbose, which just means you get a lot more data about it. It's going to stop and be really picky and dig through everything. We'll see it on the Ubuntu GUI here, and then we'll look at it in the Nmap a little bit. It's against the 2019 box. I'll do one more where we scan kind of a network and it goes through and looks at things. You can see it goes through and finds open ports here. If you know the ports, you'll know what they are. Things like DNS and SSH and web server and things like that. And it'll go through and find those things. But then it'll go on and continue to do a little more poking at them to try to understand what are they, right? It's pulling out the SSH key. So it actually made an SSH connection to the SSH server to get the keys out of it to try to understand what's going on. It's trying to fingerprint things to understand more about the versions of what's in there. What version of IIS is running? These kind of things can be used for great effect, right? You want to know, hey, is my box up to date? Maybe I'm working with a piece of IoT gear that I didn't even know had a web server on it. Oh my, there's an attack surface I didn't even know about. So Nmaps can give you some of that kind of information. You can see here it's going through and doing a bit more thumbprinting and that kind of thing. With the detailed version, it was able to find out that it was in fact, Windows 2019, and it came up with its computer name and came up with a bunch of other stuff that we didn't get in the earlier mode. SMB security modes. This is beginning to get into security stuff about what it can and can't do. And that was only one IP address, but it did take like 3-4 minutes to get that information. It was not fast. So it can take a little while to get that kind of stuff. We come over here to Windows. And we're going to see it's going to get very similar information. We scroll up to the top here. It's going to look really similar. We're running the same command. It's going to color code it a little bit, which I guess is nice. And it might organize it a little bit differently, but it's effectively going to be the same information. We're going to see TCP fingerprints. We're going to see SMB discoveries and trace routes. It's going to trace route to it and that kind of thing from us to them, so you can get a little more information. When we come down here and look at it, it's actually filled out the Windows icon on it. It knows it's a Windows host. Since none of our ports went away from the last time we did it, which was just a couple of minutes ago, it's not going to change a lot. Our topology is not going to change a lot. We're going to get a lot more information in here. Amusingly enough, since it claims it's 2019 in the other scan, it didn't seem to want to update this for some reason. I don't quite understand how that works. It's a good question. Could be a limitation, I suppose. And again, it shows the different scans we've run. This is just a history of what's been run against this box, so you know, how did I get this information? Kind of stuff. Thank you for joining us for this Tech Nugget. I appreciate your time. One last note on the way out. I'd like to remind you that these tools can be used for evil, and not to do that. Make sure that you use these tools for good. Don't be evil. Learning a tool does not make you a security expert, but it can certainly make you more knowledgeable about what's going on in your network, and should be taken that way. All tools will only tell you as much as they can, so don't consider yourself an expert on security just because you've used Nmap, although it can definitely be used as a tool to help you understand a good bit more of what's going on your network. We'll see you next time for the next Tech Nugget.